Uh, Most probably all of you already know me, but for those who don't, let me introduce myself. I'm Joan Frances Jimenez. I'm a product manager of some of the control products we have in Delta, like the DOP 100 and some PLCs like AES and DBP PLCs. And I've been working for Delta since 2015, so around 6 years ago. But I previously, my former company was Mecánica Moderna, which is one of the distributors of Delta in Spain. So in fact, I started to work with Delta products around 2006, more or less. Uh, uh, One of the things that thanks to this around 15 years working with Delta, one of the things that I could see is how we are doing the transition from, let's say, component provider to solution provider. This is uh, something in a transition in which we are still involved. We are moving in this direction. And one of the first things we asked to our R&D people in Taiwan is that if we want to move in that direction, one of the things we really need is to have a single platform to program all much of our devices. That's why we start to define and to create the DIAStudio a few years ago. And inside of this platform, this DIAStudio, one of the main tools we have is this DIAScreen. And this is a topic or the main topic or that I will show you during this training of today. Okay, sorry, I forgot to mention, take into account that this training will be, it's being recording. And once we finish, we will put it on YouTube. So you can download it or you can see it whenever you want. Okay. Okay. Let's start then. This is the agenda for today. Firstly, we will have a quick introduction to what is DIAScreen. And after that, we will go with the main two topics in this training. First one is the DIATag. And the next one after DIATag will be the Lua Programming. Okay, you will see different examples on how to program by use of Lua. Okay, so let's start with the introduction. What is DIAScreen? As I said before, the main reason to create DIAStudio is because we need to have in a single tool, in a single platform, all the programming languages we have in Delta. And not only to have a single tool, not only for that, but also in order to being able to easily change data between the different softwares we have. So between the programming of the HMI and the programming of the PLCs, programming of, I don't know, AC drives and servo drives, etc., etc. So we need a tool that helps on the integration on all the products. So moving, as I said before, from component to solution. That's why we need this kind of software. And one of the tools we have is DIAScreen, which is not only ready to program our top 100, the HMIs, the touch HMIs, but it also includes the TP panels and also the soft HMI, let's say, the virtual HMIs we have in some of our motion controllers, like for instance, the AX8. So even if this is true, to be honest, we have a single tool, which is DIAScreen. But for instance, we have two different users interfaces. It's quite different, the interface you have for DOP 100 and the one you have for TP. This is also true. But at least we have everything on a single tool in this case. And apart of having a single tool, the other main benefit is that we want to have integration of different products on this platform. It means that we need to easily and let's say in a convenient way, we need to easily share the tags, share the variables that you create on the PLC side, the PLC programming tool, which is a dia designer, also with the DIAScreen, the HMI side of the platform. This is we will do that thanks to DIATag, as I show you later. And apart from this, I know that the second thing that I want to show you today, this is something which is not new because we already have it since the beginning when we released in 2006, 2007, when we released the 100 devices, which were programmed by DOPSoft. We already got this, the Lua programming inside. But we have the feeling that this is a really powerful tool that we put it there, but most of our customers are not taking advantage of it. And that's why we created this training, in order to show to all of you what we can do with this new tool, with this Lua, and how powerful it is, and at the same time, how easy to program it is. That's why we created this training. Okay, so let's start with the DIATag. As I said before, this DIATag is the tool, the feature that allow us to quickly, easily, and in a very convenient way share the variables, the tags between the dia designer, which is where you create those variables, the programming of the PLC side. How we can share it easily with the DIAScreen, with the HMI programming. And once you have here all the variables we have created in the PLC, you can use it not only on, let's say, an object like a numerical entry or numeric character entry, this kind of object, but also you can use it, these tags, into the Lua programming or even on the macro. So you can use everywhere in your DIAScreen project. The best way to show you how does it work, I think it's to show a real project. Sorry, because I have a little cold, so you will hear me coughing from time to time. Sorry for that. And let me share with you. Okay, 1 second. This is a PLC project that I have on a real PLC I have here close to me. Okay, it's already running, this project. And here we have the global variable and some variables that are using this small project, okay? You can see here. And also let me share with you a DOPSoft project that I have, which is using the same tags. How to open the DIATag dialog. You can do it from here on the project tree on the left side of the DIAScreen. You will find this DIATag, something that you will not find on DOPSoft, on current DOPSoft. Even they are very, very similar. This is one of the main differences between DOPSoft and DIAScreen. So if you double click, it will open the DIATag interface. I already have this variable, but if I want to share with the project, a PLC project that I showed you before, I need to select. I want to select, this is the PLC AS218PX test. This is the call. This is how I call my PLC in my project, and my PLC project, you see here. And now I have to select, which is the link name. The link name belongs to, it refers, sorry, to the name that is set here on my project. Okay. I think some of you have Jonathan has made a question. Yes, please. I didn't say before, but please do not hesitate to interrupt me at any moment you have any question. Yes, Jonathan. I think you're muted, in case you want to speak or if you want to write. I cannot hear you, Jonathan. Can you try maybe by writing on in the chat?
Raising hand.
Yeah, Jonathan?
Oh, by accident, sorry.
Oh, an accident. Sorry, sorry. Okay, no problem. Okay, then let's continue. I was showing you that this DIATag, at the moment we try to create this link between the DIAScreen project and the DIA Designer project. We need to indicate which is the name of the PLC on the DIA Designer and which is the name of the link we set up on the options communication. Okay, so I say okay, and at this moment, those two projects are linked together, are synchronized. What means synchronized? It means that at the moment I create, I don't know, it's 1, 2, 3, 4 new variables, like these ones. It's okay. I should be able to see them on the project, but I need to first compile. If I don't compile the project on the Dia Designer side, I won't see them. And you see, as automatically, I didn't have to export and then import as we did many other times. I already automatically get those variables here. Okay, the same way, not only by adding, but also when I remove. Sorry. If I compile, before compiling, you see everything is here still, but at the moment I compile, those variables disappear. Okay, so you can see how easy it is to have to share all the variables automatically in a very convenient way between Dia Designer and DIAScreen projects. Okay. So let's start with the next topic, which is Lua programming. Okay. Lua programming, as you can see here, it's basically a high-level programming language, something similar to Visual Basic, to C++, Ball and C, you know, those kind of programming languages that most of programmers in the industrial side are very used to. And of course, the programmers which are not focused on industrial, so let's say general area programmers, are very used to this kind of language. So it makes very easy for customers to enter on the programming of GOP 100. It's in a different way of what we have with macros. Okay, they are also very powerful, but the macros is something created by Delta. It's not a standard. And in the other way, Lua, it's the other way around. It's a standard, not designed by Delta. So you will find many examples and tutorials and in the internet. So it's very easy to learn how to use it. The program editor, again, I think it's the best way to show you is by showing a real project. So it's very easy to get into the Lua programming. You just need to go again to the project tree on the left side of your DIAScreen project and double click into the main. And here you have the programming area. So here you have the place where you will put the code lines. And in order to make it easier to program, we have added this tab, this program example assistant, which is very useful because you have here the complete list of functions we have for the Lua. They are grouped depending on the functionality they are related to. For instance, this is basics. In order to read, write internal memory, in order to read, write internal memory by the $M type, the static. How to read, write on the slave devices you have connected to HMI, etc., etc., etc. We have many different kind of functionalities. And apart from this list, you also will find, like, for instance, we select this screen open, you have here some explanation of the function you are going to use. And even more, when you go to the programming area, if you put your mouse over a function, you will get a tooltip screen, again with the basic information related to this function, where you see which are the different parameters, the arguments that this function requires, and also which are the, let's say, outside output parameters, output parameters that it returns when it is executed. Okay, so you see it's quite easy to use this Lua programming. Let us start with the training itself of this Lua programming. In order to show you how to program, I think the best way is to use a real example. So what I have prepared is one example for each one of the different topics of the Lua programming that we are going to see. Here in my table, I have a couple of devices. I have a real DOP100. In fact, it's a DOP107 EG. And I have also an AS200 PLC communicating together. Most of the cases were going to use only the HMI, but in a couple of examples, we need to have communication with the PLC. So that's why already have here. And by the use of the VNC, I will show you also on the screen what I have on my HMI. So you can see the real how does it works really on a real HMI, not simply by doing a simulation. Okay, let us start with the basic structures, with the very the easiest or the basics of programming in Lua. I will show you three in this project, three basic statements: the if, the for, and the while. So very basic, as you see it. But it's good to start with the more simple things, and then we can go further. So in this example, I have created a couple of numeric entry. I call them B1 and B2. And then I have another, in this case, in a character entry where I will output the result of this comparison. So when B1 is bigger than B2, I want to show here a text saying B1 is bigger than B2. Also in the other way, when B2 is bigger than B1, or when B1 is smaller than B2, then I will show this text, B1 is smaller than B2. And in case they are equal, I will show you this text. How does it work? Or how can I do that? By using if, by simply doing that. Using if B1 is bigger than B2, this is the text I want to show. Else if it's smaller, then this is the other text. And if it's not bigger, sorry, or smaller, then it's equal. This is the text. Okay, so let me open the project. Here you have a project. Let's download it. Okay. Okay, it's already downloaded. Now let's use VNC. So you can see here what I have in my real HMI. So as long as these two variables are equal at 0 now, this is the text that I'm showing. Okay, so the program now is doing if B1 is bigger than B2, no. Else if B1 is smaller than B2, no. Else then it enters the program, enters in that point, and shows this message, B1 equal to B2. You can see here. At the moment I modify this one, I put, for instance, 5. Now automatically it changes. Put here 9, the other message. And if I make them equal again, I got again same message. Very easy. Next statement, the for. How does it work? In this case, it's a loop type statement. And what I'm doing here in this example is we will have a couple of numerical entries where we put two different values. And what I want to show here is the sum of all the integer numbers between this one and this one. So it means, for instance, if I put here 4 and I put here 6, it means that I want to show here 4 plus 5 plus 6. If I put 4 and 7, the result here, I want to see 4 plus 5 plus 6 plus 7. Okay, so this is this simple, silly question, silly example. And the for, it works in that way. For E, which is the index, it's equal to star until you get to the last. Start is the first value, last is the last value. I simply keep adding the value. So starting on 0, 0 plus the first number, the second, the third, etc., until I get to the last. So let's see how does it work. Now 0 because I have the same value on both sides. But if I put here, I don't know, 9 and 8, 8 plus 9, 17. But if I put here 6, it's 6 plus 7 is 13 plus 8 is 21 plus 9 is 30, sorry. So here you see how does it work. Again, it's a very simple example just to show how the for works. And the next, the last of the basic standard that I want to show you is the while. It's again a loop statement, so similar to for, but in this case, it is keeping doing the loop until this value, the value you put here, becomes false, or if you use inside the loop the break instruction in order to get out of the while. In this case, what we are doing here is we will put a limit. It could be until 9,999, and we will be inside of the while summing every time until I get to this value, to this limit. Okay, so what we will see is that when I put here 900, for instance, nearly at the same time it will appear the 900 here, but it is not directly read and write. What we are really doing, it's entering into this loop, executing the loop for as many times as you put here in the limit, and at the end I show the value that I sum, the total amount of this the sum that I made, which is the same value of the limit. You will see. It's nearly at the same time because the cycle is very small, and so it's very quickly. So you didn't see the difference, but it really, in this case, when I do that, it's the loop is only executing 12 times or 1 time, and in this case, is executing nearly 10,000 times. But you cannot see the difference because it's very quickly. It is done very, very quickly. Okay. So that's the basics of the loops and the if functionalities we can use. I'm pretty sure you already use it in other languages. But you can see as it's in the same way, it's programmed the same way. The next topic that I want to show you is the function, because in order to program in a very convenient way, you can, oh, wait, I think there's a question. Okay, it's from Victor. Okay. The same thing to you that you can write your questions at the queue, questions and icon, and you can also use the chat to ask your questions. Okay. So the function is a really nice, convenient tool. At the moment you want to create your own functions apart from the ones you already have in Lua. And it makes, let's say, more efficient the programming. How does it work? In order to create, in this case, we will have this example. What we are going to do is to have these three numerical entries, and this function, this program in the Lua, what this is going to do is to show in this output numerical entries. In this case, for the O1, will show the value you have here plus 1. O2 will be the value you have in I2 plus 2. And O3 will show the value you put in I3 plus 3. That's very simple. In order to do that, we will use this function that we will call it myfunc. It has 3 parameters, 3 input arguments, D1, D2, and D3. And what we do inside of this function simply is to create the R1, R2, R3, which will be the return parameters. And R1 will be equal to D1 plus 1, R2 will be equal to D2 plus 2, and R3 will be equal to D3 plus 3. Once we have this function created, the only thing we need to do is to first, in my program, in my Lua programming, I have to read these values, I1, I2, I3, and put it into a Lua variable by use of this function that we will see later in more detail. And once I have in Lua the values here, I just simply need to call my func. So my func, the parameters I1, I2, I3, and I know that they will return the O1, O2, O3 result. But this result is still on the Lua side only. I need to put it, all these results, into the numerical displays or numerical entries I have here. So I need to call again to these functions that are used to write the values you have on Lua variables into internal memory of the HMI. Okay, again, this is something we will see later. Let me open this project. Okay. As you can see, this is the program. Just have what I show you. We have the function declaration, and then have the main while loop. And here I read the variables, I call my func, and then write the result into the variables output variable. So I read from here, call the function right here. Okay. 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 Wait. Okay. Okay, on here, let me show you the BNC. So here you have I have on Realism I. So as long as the input values are all 0, then I have 1, 2, and 3, because remember, this is I1 plus 1, this one is I2 plus 2, and this one is I3 plus 3. So I can change. You see how the values move. Okay. Again, very easy, just to show you how this function works, or to create your own function. It's very easy. Okay, let's move ahead. Next topic that I want to show you is a memory library, which is the one that we use in order to access to the internal memory variables in the HMI. So I mean the $0, $1, $2, whatever we have there. The way to read it is by use of these functionalities. We have also, I didn't show you in this training, but we have exactly the same for the, let's say, retaining variables in the internal memory. So the $M0, $M1, but it's exactly the same. That's why I didn't put it here. It's exactly, it works in the same way. Okay, in this example, what we are going to show you is how to read and write. So the idea is, let me show you the project. Project, no. The idea is that how does it work? We will put any value here on these variables in this numeric entry. This is a button just associated to an internal memory area. And this is a numeric, sorry, a character entry, also again assigned to a numerical, an internal memory. And what we are going to do by the use of Lua is to read from this, from in this case, for instance, read from $100 and write in $150. So whatever I put here manually, we will see as it disappear nearly at the same time immediately in this order. So whatever I create, I write here, it will appear here, and so on. Just to show you how easy it is to read and write on internal memory. Okay, let's return to the presentation. Okay, so for the read, the function looks like this one, mem.inter. And then we have different functions depending on what? Depending on the data type we want to read. For instance, this case, we are reading a 16-bit variable of word type. So we will have to use the mem.inter.read. And the number here, it means which internal memory variable I want to read. 100 means $100. Okay, as easy as this. In the case I want to read a double word variable instead of a read, I need to use this read DW for this item here. In case I want to read a float, a 32 bits float, I need to use the read float. And in case I need to read a double variable, so it means a float of 64 bits type, then I need to use this read double. For the bits, I have the read bit, and for the ASCII characters, the strings, I need to use this one, the read ASCII. Okay, in the same way, when I want to write, I have the similar function, but in this case is mem.inter.write. And again, depending on the data type I want to use, I have the .write, .write w, the dw, .write float, .write double, write bit, or write ASCII. It depends on the data type you want to read or write. Okay. So let's try. Okay. As you can see here, the program is nothing more that I show you on the presentation. The reading part and the writing part. That's all. Okay, let's start the BNC. So if I want, for instance, let's modify this one first, and you see that automatically the value I put below, it appears above. No matter that the type I select. Also for the bit, it works in the same way. I read this bit, and then depending on the value of this bit, I write it on this bit. And also for the text, just SC. Okay, it works. Okay, we have seen how we can read and write internal memory, and the next step, the next topic is to the same, to read and write, but in this case not to read and write internal memory of the HMI, but the link, what means the slaves that you have connected in your HMI, no matter if they are connected by serial side or by Ethernet connection. In this case, the example will be similar to that one, but slightly different. Okay. What we are going to do here is a little more complicated, let's say. Firstly, we will put the values, original values, let's say, manually here, 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 and here. And first, we will read from internal memory, because as you can see here, all those numerical entries, this button and this character entry are associated to internal memory, $100, $200, $300, etc. So first we will use the read internal memory function that we have seen before. Then when we have those values in our Lua, into a Lua programming, we will write into PLC. Okay, as you can see, what we have in this numerical display, it is a PLC variable. We are not reading HMI internal memory. We are reading directly what I have on my PLC. Again, here, this bit, it's also coming from PLC side, and also this character display is coming from PLC side. So what we are doing here is first read from internal memory. Then when I have this value in Lua, I will write into PLC, and the next step will be read from PLC, and the result will be written into internal memory. So what we will see here when I run the program is that whatever I put here, it will appear after some tenths of seconds here and later here. Okay, let me show you that on the programming. So in fact, what we are doing first is to read, for instance, in this case, the first one, read the internal memory $100, which is the value that I write on my HMI, and the result of this reading, I will write it on my PLC by the use of link.write function. This is the first one, which is a word, but in case I want to read or write a double word, I have a specific function. Again, write double word, write float, write bit, or write ASCII. Okay. In the same way, I have the read functions. I have the link.read dot read double word dot read float dot read bit and dot read assay. Okay, let's see how does it work. Let's connect the BNC. And as I said before, whatever I put here, we should be as it moves to here. So the real PLC variable. And then from PLC, I read it from PLC and write it again to internal memory. Let's try. Okay, have you seen? It's very quickly. It's zone, but you can see the difference between the first writing and then the next one. Again, for the double word, for the float, also the bit, and okay, you see it's a quite similar function to the ones we saw before, the ones to write into internal memory, but in this case, it is used to read or write into a slave, HMI slave. You just need to indicate if you want to read the tag or the variable of the PLC where you want to read or write, and in case you're using the write, okay, the write, apart from the variable you want to read or you want to write, you need to indicate, of course, which is the value you want to write in this variable in your slave. Good. Any questions so far?
Can you hear me now?
Yeah, we can hear you.
So yeah, I just wanted to ask, what is the purpose of this programming language? In essence of the, if for example I connected the HMI to PLC, it just transfer the variables automatically. So why do I need this method?
Yeah, I understand. The point is that this programming language offers you a very powerful programming language. I mean, in case you need to do, let's say, calculation, mathematical calculations, or you need to do, for instance, file management, you need to read and write from files or whatever, then it's the best way, or even send emails. The best way is to use the Lua programming because it offers you a very powerful tool for that. If your application is so simple that only needs to read and write from PLC, you will not need Lua at all, of course. But
Okay.
it isn't in the case you need, let's say, advanced programming in your application, then you need to move to Lua.
I see. And okay. And where do I write the code exactly? In the macro?
In the project, you mean?
In the
Here.
macro?
No, you can use the macro because macro is, let's say, the old way you used to do some advanced programming. This is something we did since the very first devices we released it, the DOP-A, a very old HMI. We started to use these macros, and it's powerful also. We made many complicated applications by use of the macro. But at the end, if you need more power, more powerful programming, more advanced programming, you need to go to Lua. If you want to use Lua, you just need to go to this in the project tree, double click into main, and here you have the programming area. That is where you need to put all your code.
Okay, I see. Thank you.
Okay, now you're welcome. Okay, so let's start with more, let's say, more advanced functionalities of the Lua. First one is the file management. So the capability to create your own files into the memory of the HMI, but also in the USB or SD in case your HMI has a SD card slot. You can also create files there. and not only create but also write and read the information in those files, and also delete, of course. Okay, so again, I'm using an example in order to show you how does it works, because I think it's a better way. It's okay to show the theory, but the best way to understand how does it work is to show a real example. In this example, let me first download it. Okay. Okay, I got it. In this example, we will have uh, this folder, the display, where we will see what I have in my USB, because I'm using USB drive in order to create the files and store it. And by use of this button, I will create first the file in case it is still not created. Then by use of this second button, I will write some information in this file. Then I will be able to close. At the moment I close the file, I will be able to read its contents by the use of this object here. And finally, I will show you how to delete a file. In order to create some, let's say, some stuff or some data to put in the file, I created this temperature and counter, which is basically are two values in internal memory, $1000, $1002, which are increasing. Okay, let me show you the BNC. So here you have, these values are continuously increasing. And at the moment I create a file, I open it, I will write all this data. The data that is this moment in the temperature and counter will be written into the file. Okay, let me get back to the presentation and I will show you how does it works. The different functions we have. Okay. So the first, as I said, is how to create a file, or in the case it's already created, how to open this file in order to read and write from that file. The function we need is this one, file.open. And it has a couple of parameters. The first one is disk ID, so where my file will be stored. It can be 0, which means internal HMI memory, 2, which means USB, or 3, SD, in case my HMI has the SD card slot. Okay. And the second parameter is a file name. So I need to indicate which is a file name that I want to open or create in case it's still not created. For this simple example, I create the file name here inside the Lua, but you can also, of course, you could, in case you prefer, you can add here a character entry and use this character entry to indicate the name of the file you want to create. It's very easy. Just simply assign an internal memory to this character entry. And once you are inside the Lua Programming, instead of using this, you put field name equal to read internal memory in ASCII type and read the internal memory you have associated to this character entry. So you can do it whatever you want. This is just a simple example. So I fixed the name. Okay. And this function, file open, it returns a couple of parameters. The first one is the red. It can be 1 in case there is a success, or fail. In case of fail, it will return a 0. And I use this variable in order to show in this display. I paint it in blue in case it's success, or I paint it in red in case there is a problem trying to open that file. Okay. The second parameter that this file.open function return is the file handle. This is very important because the file handle is the way you're going to make reference to this file from now on. At the moment the file is open, you will no longer to know the file name, but when you want to read and write and whatever you want to do with that file, you need to use the file handle. Okay, you will see later when we use the write instruction. Okay, the next next part is when I have already opened my file, but I want to create to write data in it. In this case, the function is called the file.write. I need to send to this function the file handle, as I said before, the data that I want to send, that I want to write in this file, and also I have to indicate the length of this data. In order to calculate, I use this function, string.length, and put data. So automatically it's updated, the length of the data. And before I use this file.write, I need to cook that data. So because as you see, the values I have here, they are numerical integers, but I need to convert it to a string. Okay. So firstly, how I will cook this data? I firstly will read the temperature by use of mem.inter.readFloat. You remember this function we've seen before, and put it inside a Lua variable. The next step is to convert this numerical variable into a string. I use this string.format. This is a function that converts from numerical to a string. Then I will read this value of the counter. In this case, it's not a float, it's a double word. So I need to use this function. And once I have the value read, I will convert again to a string. So in value 1s and value 2s, I have the string with this numerical, this number converted to string. But I want to not only put the values, but I want to show some text like temperature and counter. In order to do that, I need to use the concatenation tool. So my data, so what I'm going to really write in my file will be temperature. This is a string itself. This dot dot means concatenate, so put together. Temperature, then I put together with that temperature text, I put the string of the value of the temperature. Then I move to the next line. I put the counter text. This is a text, this is a string. And together with it, I will put the value to s. So the string where I have converted the value of the counter. So I will show you something like this in my file. Okay. You see how firstly we need to cook the data, and then when I have the data ready, I write by user file.write. Okay. This is exactly what I showed before. Here you have the instruction file.write, how does it work? And again, depending on the result, I will find in blue or in red this let. Finally, once we have the file already open and writing the data inside, we need to close it before I can show this data on the text editor that I have also on my project. I need to close it. If the file is open, I cannot show anything. You will see later. And in order to close the file, it's very easy. It has a single parameter, which is the file handle, in order to indicate which file I want to close. Okay. There is still the delete, but we will see later. Now let me open the VNC again. Okay, here you have. This is my USB. Now I just have one TXT file. This is something that we will use in another example, the one that related to the mail sending. Okay, this by use of this display, I can see what is inside of this file. Okay. Oh, sorry, Jonathan, I didn't see. Please, is there any question? I cannot hear you.
Sorry, by mistake.
Oh, okay, no problem, Jonathan. Okay. So let's start with that. First, I will try to create the file because as you see here, the file it's not created. Okay, everything works fine. We have a blue, which means success. And here you file. In fact, here you have the file. But as long as the file is still open, I cannot see anything when I try to display it. Okay. So I need to first write some data in the file by use of this button. Okay, so I don't know, 1, 2, 2, and 3 values. Even I already have written into the file. If I click on display, I still cannot see anything. Why? Because the file is still open. So remember, first I need to close the file. So now the file is closed, and theoretically, at the moment I click on display, I should be able to see the contents of the file. Perfect. Here you have. This was the first time I click. I got this temperature and this counter. Second time, this temperature and this counter. Third time and the fourth time. Here you see. Okay. In case I want to delete, as long as in order to delete the file needs to be closed. Otherwise, you cannot. So there is no any handle for the file, any file handle. So in this case, the file point delete function, it requires not the handle to that file, but to indicate which is the disk ID, so where where the file is stored, and again the file name. So this is the file name. I use it in the open file, and so again I use the same in order to delete. Okay. Let's see how does it work. Okay, you see how the file has disappeared. Okay, I can display the example.txt. And if you want to create a new one, just simply open file again, write, close. Now I can display again what I have inside. So you see how easy it is, again, to convenient way to create your own files. You can store there whatever you want in the way you prefer to store all this data. You no longer need to use historical functionality of your HMI. You can create your files whatever in the place you want, and to store the data you prefer there, no limitation. That's why this kind of applications is where the Lua is really needed, and why Lua offers new possibilities to the programmer of top 100. Okay, there are many other instructions, of course. I only show you some of them, some of the management. 1 second, of the file management. But if you go to main, you see here I always use the one: file open, file write, file close, and file delete. But you see, we have many functions. Each of one, you have, remember here, the kind of help on how to use it. And even if you move your mouse over any instruction already put in the programming area. You also have this tooltip window with advanced information regarding this functionality. Okay, so let's move ahead. The next topic I want to show you is the screen management. This is quite simple, but again, if you're doing some programming on the Lua, sometimes you already need from the Lua side to change the screen you are showing to customer, or maybe you need to open a sub-screen, or even sometimes you need to create a snapshot of what is seeing, what is showing on the HMI at this moment, and you can store this snapshot in a USB memory or an SD card or whatever, so you can later you can share with another one, or maybe by use of other functionalities we have, for instance the FTP server of or maybe by the use of mail sending, you can send by mail this snapshot. So you see, yeah, we have many tools that they can work together to do advanced things in your projects. Okay, regarding the screen management, first one I want to show you, it's the screen.open function. It simply need to indicate which is the screen you want to open, you want to move, and that's all. It can be an let's say a normal screen, or it can be a subscreen. If you want to trigger a subscreen, you use exactly the same function, the screen.open. Let me open the project, the sample project. This one. Okay. And let me now show you the BNC. So I have here the open screen that will open whatever the screen that I put here in this numerical entry. And this subscreen, let me show you. In this project, I have the main screen, which is this one, the number one. Then I have two, from screen 2 to screen 10, there are normal screens. The only change is the screen title, screen 3, 4, 5, whatever. And the number 11 is a subscreen in this case. When I use this one, the open subscreen, I'm using exactly the same function, the screen.open, but in this case, I'm fixing to 11. So the one which is on a subscreen. Okay. So let's try it. You see it. At the moment I put 9. I open screen 9, etc. And if I want to open the subscreen, just click here, and here you have the subscreen. You can also see like it's in the same way. Clicking this button is the same as I click here, because it's the same function. And in order to close the subscreen, you can close it by here, but you also can use a specific function, which is called screen close sub, and indicating which subscreen you want to close. So by clicking here, you see how the subscreen is closed. And for the screen capture, you see it's very simple. You can do it in a simple way, which is simply indicating I want to screen capture, and where do you want to store that snapshot, in the USB or maybe an SD card. But if you prefer, and automatically it will store in a folder with the date, and the file will have the name will have the time at the moment you created the file. But if you prefer, you can indicate to this same function, screen.capture, you can indicate which is the file name you want to use and the file path. You can do it more, let's say, customized to your needs. Okay, I did it in the easy way. Just create by yourself the folder and the file and the file name. Sorry. So you see here, every time I click here, if everything goes well, I have this one in blue. Let me show you. Let me take out the USB from the HMI. We'll put it. Let me show you how does it appears. Okay. These are the contents of my USB. As you see, this is the example file that I already have in order to use in with the mail. This is a text file we have created before with a previous example. You see, yeah, the 4 data we store there, or the five set of data we store there, and also automatically when I click on the snapshot and the capture function, the HMI created this folder with the date of today, and here you have the 2 pictures. Okay, these are the 2 pictures I took from this HMI. Let me return to the USB drive on my HMI. Okay. Okay, everything's ready again. That's all from the screen management. Okay. The next is the draw functions. This is something also, let's say this functionality is not for all the applications. Not all the applications need the draw, but in some application it is very, very, very useful. For instance, in kind of application where you need if your machine is a bending machine, for instance, it's you need to create a shape on a tube or whatever, on a metallic part, you need to create a shape. And depending on your configuration of the machine, you want to show to the customer what he's going to have. So you need to create a kind of drawing of the result of this machine. In that time, you need a way to create your own drawings, not in real time. I mean, not that you don't need to open DIAScreen to create or import the file and send to HMI. That dynamically you can have this drawing. That's in that kind of application is where the draw function are very, very useful. Let me open again the project that I prepared to show you those functionalities. The Lua draw and download. Okay. Here you have it. In this case, we are going to show you 3 main functions. The first one is to draw a point, so a single point. But in order to create many of them, I will use a random function to create automatically on each cycle of Lua. I will create a random point and write it here in this black part of the project. Okay. Then I will show you how to draw a line and how to draw an ellipse. on ellipse or on a circle, depending on the parameters we put there. Okay, and finally, I will show you also how to clear all the drawings we have made. Okay, let me return to the presentation. The first one is to draw a point. Here you have the instruction, the function. It's draw dot point, and the parameters it needs is basically the coordinates cx, cy, and which is a color that you want to use for painting that point. As I said before, in order to create this automatically a random point, I will use this function, this math random set, and then once I have these points automatically, sorry, by use of this the random set and the math dot random, when I have these random points, I will draw it. That's all. It's so simple. Okay, let's see how does it works. You will see, like at the moment I enable these random points, it will start to generate points, and you will see here as they have been painted in green color. Okay, I'm not sure, but I assume even with the resolution change, you should see these points are written in your screen too, right? Even if they are too small, I assume you can see them. Okay. The next function that I would like to show you is the draw line. In this case, we need to the parameters we need to enter is the coordinates of the initial point, the coordinates of the end point of this line. We also need to indicate the color, of course, and the pen width, so how the width of the line. Okay. Let me stop generating random points, and here you have. In this case, I have a fixed parameters or fixed arguments from 500, 400 as initial point until 700, 400. So it means a horizontal line of 300 points of length. Sorry, 200 points of length. This is what you see here. And if we want to show you the last, I want to show you also, sorry, the last, which is ellipse. In this case, the ellipse function, it needs first the coordinates of the center of the ellipse. Okay, so it's more or less here. Then I need to indicate which is the width and the height of a ellipse, and of course, in which color I want to paint the background inside the ellipse. Okay, again, for this simple example, I put fixed values, not variables. And here you have the ellipse. Okay, and the last is the clear. Just simply call to draw dot clear without any argument, and automatically whatever you have written, it's clear, and you can start to work to paint new objects in your HMI screen. Okay. Again, I am showing just some of the functions we have, but take into account that we have many of them. Okay, for instance, for the draw, we have also a function which is called an Anti-Aliasing. So you will show these the figures or the ellipse, the line, whatever, in a more smooth way. Okay, by enable this function, and also take into account that our R&D, even if you can see here there are many functions. Take into account that our R&D is putting a lot of effort to add more and more functions. So it is not only what we have now, but take into account that remember that our R&D is keeping adding more and more functions in newer versions. So we hope we will increase the amount of functionality we have here. In case you find out you need any for your project, just let us know. I cannot promise you that in a short time we will integrate it, but if we found it's very interesting, not for many projects, for many applications, for sure we will implement it. You can rely on that. Okay, let's move ahead. Another very interesting functionality that Lua adds to the programmer of the W100 is the mail sending. This means that so far we already were able to send mails, but usually these mails have to be, let's say, associated with alarms or this kind of thing. So you cannot send mails whatever you want, and you can also attach or customize the information you put on those mails. So this is why one of the reasons why Lua is so powerful is because it opens you new possibilities. In this case, by use of mail, where you can customize whatever. You can customize to who you're sending the mail, what is the content of that mail, which are the files you want to add as attachment on that file, etc., etc. Okay, let me show you how. First, let's open again the file, the project for this. Okay. Okay, let me open the BNC viewer. Okay, here you have, project has been downloaded. In this case, we again, this is, I have the USB memory in my HMI. This is what I have there. One of the files I have is example.txt. You can see here what you have inside. This is the other one that we show it. We use on the file management example. Okay, and also here I can modify which is the receiver of the mail that I want to send. Okay, by default I put my email address, but here you can modify it and put whatever you want. Okay, and the idea is that I will send the mail in this case, or send the mail with an attachment, and the attachment will be this example.txt file I have here. Let me go back to the presentation because I want to show you the steps we need to follow in order to set up the SMTP server into the W100. First of all, we need to set up the P address on the HMI. Okay, so the normal settings, but it is important also to set this one. We need to set up a DNS server IP address because when we indicate it, which is the server, the SMTP server address, we will use this kind of, let me make a zoom. We will use this kind of smtp.gmail.com. There is no need to put an IP address here. It's more convenient to use this kind of notation, let's say. But if you want to use this, you firstly need to indicate a DNS server for the W100. Okay, so after you have set up the IP address and the DNS server, we need to move to the SMTP tab into the network settings here in the configuration, and again indicate, which is a SMTP server address, which is a server port it uses, which is an account address we are going to use, that we need to use the SSL encryptor. This is very convenient to do. And then, of course, we need to indicate which is the account and the password, because we need to connect to this server. So we need this the account name and the password in order to use it. Okay. Once we have done that, we need to move to our SMT server. And for instance, in case you want to use the Gmail, which is very popular, the Gmail SMTP server, you need to be sure that you enable this. You need to enable the allow less secure apps. It needs to be on. Otherwise, you will send, let's say, .100 will send the mail to the server, but the server will not accept that mail. So please make sure you have activated it and double check it from time to time, because if you are not using this functionality for many time, Google automatically sets it to off. So you need to be careful on that. Just if you use it usually, let's say frequently, you will face no problem. But if you keep too many time, let's say, without using this mail, you may find that you get some error when trying to send a mail, and that's probably because Google automatically put it to off. So take into account, be careful on that. Okay, so once you have already set up the let's say the internet connection and the SMTP on your .100, you already set up also the server side, the Gmail in this example. Then the next is the Lua code, and it's quite easy. Again, the function in order to send the mail is this one, mail.send, and you just need to indicate which is the receiver mail to who you want to send the mail subject, and the mail content. All of them are strings. So again, we need to cook those strings in order to use as parameters or arguments of this mail.send function. In this example, the receiver mail, as I said to you, let me put again this, is here. This is associated to the internal memory $500. Let me show you in the program. Here you have $500. So first I need to read $500, reading as an ASCII, and I put in the receiver mail. So I can use it directly on my mail send function. The second is a mail subject. I want to use, I want to have as a subject, again, the temperature, sorry, comma, and then counter, and then the value of the counter. And for the contents of the mail, I will use the same, but in two separate lines, okay? So I need to cook, again, this data. Remember, we did this on a previous example. So first read the value of the temperature and convert it to a string. Then I read the value of the counter and convert it to a string. So I have here value 1s, value 2s, the two strings. And now I need to cook the mail subject string that we say that it will be temperature, the value of the temperature, then the counter and the value of the counter on the same line. And very similar to that, but the content will be very similar to subject, but in a two separate lines. So I need to add this carry return line feed in here, let's say, to have it in a different line. Again, this mail send file, it will return a couple of parameters. The first one is the res. If you look here, you will see the res will be 0 if the mail sending have not started, and 1 when it started, but doesn't mean it already have been sent to the receiver. Okay, it just start the procedure. And error in case there is any problem. For instance, I use an not valid argument on my function on my mails and main send function, or maybe the SMTP server has not been properly configured on my DIAScreen project, then I will get this error. Okay, but again, take into account that this function is only referring to the part of sending the mail from .100 to the server. We are still not knowing if the server has properly sent the mail to the receiver. In order to know that, we need a second function. We need a second function which is called mail.status. This is the one that will inform us of when the mail has been really sent to the receiver. Okay, this mail status returns a single parameter, which is called it will be 0 at the beginning. If everything goes well, it will return number 1, and in case we receive these negative values, depending on which one, we can see which is the error, why the mail has not been sent properly to the receiver. Okay. So when I click on the same mail, let me go back here. When I click on the same mail, at the moment I execute the mail send, we will see here the res. Okay, so it will be 0 at the beginning and 1 when it starts to send the mail to the server. And the error, also returned by this function, will be shown in this second value here. Remember, this will be 0, means no error. And if I saw a negative value, it means that I have a problem to send the file to the server. The mail to the server. And last, in order to be sure that the mail has been sent properly, I need to wait for number 1 appearing here on the last of these numerical displays. Okay. So let's see what happens when I click on send mail. Everything goes well. You see it's put in blue. I firstly see this become a 1, then this keeps 0, it means no problem to send to the server. And after a small time, I saw the number 1. It means the mail has been sent. Okay, let me write. Let's send a couple of more. Okay, and if I move, remember that on the subject and also on the content of that mail, we should see the values of temperature and the counter that we have at the moment I click on the same mail. Okay, so for instance, after should be on the 403, more or less. Okay. Now it takes some time, to receive the mail. Let me have here my. Okay. I'm not sure you can see. I already received the first one. Okay, here you have, I had mail from .100 mail, which is the mail account in Gmail. And as a, sorry, here you have the temperature, the counter on the same line. And in the content, you have also the same information, but in 2 separate lines. Okay. Okay. Then let me show you also, delete those mails. And let me show you second option is that we can also send not only a mail, but we can also send a mail with an attachment. This is very interesting at the moment you, for instance, want to share with someone, I don't know, and a snapshot of at the moment you have an alarm on the HMI, or you have created a data file by the use of file management instruction. You get a file, a TXT file or CSV or whatever extension you want with the data inside, and you want to share with anyone by use of mail. You can do it by simply using this instruction. In this case, it's exactly the same, but instead of mail.send, you need to use a mail.send file. Okay, and again, it's very similar. It's the receiver mail, email subject, email content. So up to here, exactly the same. But we need, of course, to add information of which is the file we want to share. In this case, I fixed it that the file will be on the USB, and the file it will be this one, the example.txt, that file that I show you, I have already on my USB. And this third parameter is a password, because all the files we share are zipped. Always the file will be, I will show you later, will be inside a zip file. And if you indicate nothing here, nil, it means this zip doesn't have any password. But if you want, you can put a password on it. So in order to increase the security of the data you are sharing with anyone by use of the mail. So this zip file, in case you put a password here, will be password protected. Okay. But for the rest, as I show you, it's exactly the same as the other function. Okay. So let me. Here you have. This is the file. The example txt is the file that we are going to send. So let's click here, send mail with attachment. Okay. Again, everything goes well. This is blue. One here, which means it's stored, no error. And after a few times, we receive also one here, which means the mail has been properly sent to the receiver. Okay. Now we need to wait for some time, because sometimes it takes 1 2 minutes or sometimes less to receive the mail. But once I receive it, what you will see is that we have the mail exactly same as before, with the temperature and the counter on the same line as in the subject, and also the temperature and the counter in 2 different lines in the content. But this time we will find that we have a file attached to that mail, and it always is a zip file. And at the moment you double click on it, you can open the original file that we sent by the use of this mail. Last time I made this training for a customer, they asked us only a couple of weeks ago. They asked us if it's possible not to use the zip file, not to zip the file we sent. And this is something we are working on in order to provide to add the possibility to select at the moment you use this file, this function, the send file, that always the possibility to select if you want to zip or not. Okay, but so far we are working on that. Probably on the next version we already have this option. Okay, I already received the mail. Here you see it, temperature, the counter, 2 lines, and here you have the file. If you open, you have the example txt. Okay, if you open and you see this is the file I sent. You see it's the same content. Okay. Okay. Any question regarding the mail sending? Okay, then I will move on. This is the last of the topics I would like to show you. This is, let's say, not very common to use, but in sometimes I found some, let's say, not industrial devices, not 100% industrial devices. It's not easy to communicate with them. For instance, I found some printers. I mean, industrial printers for in order to mark the date and so on the product. They don't have Modbus communication, or they don't have can open, or they don't have Ethernet IP, especially when they are old devices. But most of them are allowed to communicate by use of Ethernet, but not, let's say, not a specific protocol like Modbus. So you need to use the socket, which is called socket, that we have TCP or UDP, and we support both of them in our DOM 100. And I want to show you how to use that. Okay, for that purpose, to show you how does it work, I use our AS series PLC that also supports the sockets communication to be the server in this case. So we have a, let me go ahead. We have the PLC, which will be the server, and the client in this case will be the HMI. How does it work? The TCP. You need first the server to initialize and create a socket, and put into the listen, let's say, a stage, which means I will just wait until someone tries to open the socket, and we can start to communicate. Okay. This is TCP, how TCP socket works. At the moment the PLC is already on this stage. From the HMI, from the client side, we can open a socket. We need to indicate the IP address of the PLC and the port he is using for this. And once the socket is open, it's already enabled communication. HMI can start to read or write on this TCP socket. In this case, we are going to use the write, not the read, and the function is called TCP.write. You need to indicate which is the socket that you are going to use for in this case, for writing. The buffer, so which is the data you want to write, the length of this data, and a timeout, not to be not to be, let's say, hung, whatever, waiting for the server answer. Okay, so you need to indicate a timeout. At the moment the client send this data write request, the server processes this request, and we can at the end receive the data, the confirmation that this data has been received, let's say. Okay, I have anything, someone have put something. Okay. Yes, it could be also work as a client, but this is something it should be shown in a different training, because it's something related to the PLC, but it is also working. If you want, Jacob, if you want, you can discuss it later. If you want to send, have you, maybe you already did it. Have you sent the question to our technical support address? Yes? Okay. Then if you haven't received any answer so far, I will look for it, and I will try to speed up the answer. Okay, but it should work. We already have customers using both reading as a server and client on the PLC side. Okay, now you're welcome, please. Let me write it down, because I need to write it down, otherwise probably I will forget it. Okay. So this is how a TCP socket communication works. Okay, and now let's see how to implement it. First part is how to create that socket, to open the socket on the PLC side. And well, first of all, yeah, you need to take care of the HMI and PLC have to be exactly on the same IP. range, of course. Okay, this is totally it's a basic, but you know you need to take care of because sometimes these we don't remember to do it, and that's the main reason of the problem. So once you have done this, you are totally sure they are in the same range. You need to first configure the socket on the PLC side. You can do it by use of let's say the hardware configuration, or you can do it also by use of functions in the Diag designer. We have a specific functions to create to configure the socket and also to open the socket. Okay, you can do it in both ways. This is from the PLC side, but from the HMI side, which is the part in which we need to focus, we need to use this instruction, the TCP.open first. In order to open the socket, you need to indicate which is the IP address of the PLC. I fix it here. This is the IP address of my PLC, the PLC that the real PLC I have here, an AS218, and also the port that I have configured for the socket. If you see, this is the port 2020, the port that I'm using. Okay, you need to indicate it also to this TCP open instruction. And this instruction, it returns whatever value over 0, so 1, 2, 3, whatever, it means success. And if you have a negative value, then it means that we have a problem. Depending on this value, it means a different problem or error route. So depending on the result, we will paint it in blue or in red in this case. Okay, here you have the VNC. This will be the open socket that I show you how to open the socket. Then we'll use the send data. What we are going to do, this is HMI variable. Okay, you see the program. Sorry. This is the project. This is an internal memory of HMI. Whatever I put here, this is something I can modify. When I click on send data, will be sent by use of the TCP socket, will be sent to the PLC and will be shown here. This is the receiver area of the socket of the PLC. So as you can see here, it's a real address of the PLC. So I'm not sending directly from here to here, but using the TCP socket functionality, okay? So for the send data, let me go back to the presentation. For the send data, is the function is the TCP.write. I need to indicate in which socket I want to write, which is the data I want to write, the length of this data, and the timeout, as I show you before. So again, I need to prepare the data. I just simply read what I have in this internal memory, $500, and I took 20 characters, okay? Then I calculate the length of this string by use of this function, string.len and buffer, which is where I store the information. Under that, the timeout, I set it as 1 second. That's all. At the moment, I call to the TCP write. If everything goes well, I will receive and 1, and this return the parameter. I will receive 1 success, and if I got a negative value, it means that I have an error. So I will modify the color accordingly. Okay. You have so first open. Everything goes well. Then now the socket is open. Send the data, and here you see as the whatever I have here, it appeared here. I can modify that. Okay, and send data. You see, whatever I put here, I use a send data. I can. Meanwhile, the socket is still open. I can send whatever I want. When I want to close the socket in order to free this socket this resource for both the PLC and HMI. I need to use the next. There's a close socket function. It's called tcp.close. I just need to indicate which socket number I want to close. That's all. If everything goes well, it will return 1. 0 or negative value means there's an error. So I will also paint in blue or in red. And the last is sorry, and I have also the TCP get status socket, which I can use in order to show status here in this one, depending on the return of this TCP status. If the socket is open or closed or active or inactive, I can put paint in blue or in red or in gray, in fact, this LED. And sorry, that's all. So now it's open. Let's close and reset. Or to delete. Okay, can do it. If I want to write again, you just open socket, and modify blah blah blah. Okay, send data. Again, if I keep open the socket, I can send the data. If I, instead of using writing, I could use also the read. For this sample, I just use the writing, but it's nearly the same. It works in the same way, okay? And just remember to, once you finish to send the data, to change data, you just need to click on the close and reset in order to get ready for the next connection. And that's all. That was all from my side.